Hey guys, let's so the next topic is explosions. Explosions. And explosions they're the same as collisions but the opposite. So suppose we had two carts coming into each other. That's what we did with collisions. We were looking at elastic and inelastic collisions. Well, now we would say, suppose you had the two carts were sitting next to each other, and the spring little mechanism inside of it, we released it, so these things shot out in this direction. That's an explosion. So an explosion. It's a really quick interaction in which two or more objects are sent away from each other, not coming into each other. So we can analyze this kind of thing. The idea is if we make the system isolated, so there's no external forces, then in an explosion, momentum is conserved. Is conserved only for isolated systems. So it's the same as the others, and the analysis is going to be the same. So let's think about this one. So let's say we had a I don't know, mass 1, and then we had another cart sitting next to it, and we had some other mass on it. So let's say it was 3 times the mass. 3 times the mass 1. So we push the little button, it shoots the spring, and these things fly off. So now we want to know, well, what's the velocity over here? What's the velocity? We'll call this A and this B. What's the velocity of B? And so we can just, since there's no external forces, external forces acting on the system, it's isolated, then we know that the initial momentum is equal to the final momentum. And the initial momentum is 0. Everything's at rest. So we get the final momentum is going to be equal to 0. And the final momentum would be the mass of A times the velocity of A plus the mass of B, velocity of B, and that would all be equal to 0. Move this over, I want to get VB, so I'll move that one over. So the mass of B, the velocity of B is equal to the opposite of mass A, velocity A, and then we could just divide by the mass B. So the velocity of B would be negative MAVA over VB. And that makes sense. We're getting this negative because this one takes off to the left, so this would be a negative velocity. So we have a negative velocity times a negative gives us our positive velocity, showing that it's moving to the right. So the analysis is pretty clean, I think. It shouldn't be too difficult. I'll do one other example. So let's say somebody's firing a gun and they want to know the recoil speed. Let's see how good my gun can. Look at that. Oh man. Put a little thing on it. All right. So it shoots out a bullet. Okay, my bullet's not so good. So it shoots a bullet, and we want to know, well, because of Newton's third law, since we put a force on the bullet, there's a force on the gun. So the gun is going to recoil. So it's going to have some velocity over here. And we could say that's the velocity of the gun, G. And this would be the velocity of the bullet. There are gases inside of here. So you have some gases that are expanding. That's what's like pushing the bullet forward. However, thinking of all the little molecules of the gas, on average, all their velocities will be in opposite directions, and this net will be 0. So we don't care about the internal forces. It doesn't have any effect. All right, so we know momentum is conserved. This is an isolated system. Let's say the mass was, it doesn't matter, but 0.01, that's the bullet. So the mass of the bullet. The mass of the gun, 3.0 kilograms. And then the velocity of the bullet, it comes out at 500 meters per second. All right. So the setup, the initial momentum's conserved. So you can actually start like this. The change in momentum is equal to 0. So the final momentum minus the initial momentum is equal to 0. That means that the final momentum is equal to the initial momentum. Yeah, these three. Now the final momentum would be the mass of the gun plus the velocity of, times the velocity plus the mass of the bullet, velocity of the bullet, all of that. The initial momentum, everything's at rest, so it's equal to 0. So we end up getting the same equation we had before if we want the velocity of the recoil. So the velocity of the, that should have been a gun. The velocity of the gun is going to be negative mass of the bullet, velocity of the bullet over the mass of the gun. And then you could just plug in your numbers. If you do that, you should get, let me look, using an example, negative 1.7 meters per second. All right, so that's it with collisions. We'll just incorporate other stuff, but there you go. That's all you need to know.